camera people, can you hear me okay? Mic is on?
You could step up behind the podium, that'd be great.
Okay, except for you're not going to see me because I'm short. Okay, how about this? Okay? All right, good evening. Sorry for our technical difficulties. Thank you for being with us this evening as we highlight the continued success of Phoenix's Cool Pavement program. I'm Brandy Kelso, the Interim Streets Department Director, which is the department responsible for managing this program. Cool Pavement has been applied to the streets in dozens of neighborhoods since 2020. At that time, we partnered with Arizona State University to conduct research tests of cool paved areas, studying how it performed and how it might be used to mitigate the urban heat island effect. Tonight, we're going to hear about from our partners about the second round of scientific study results. To kick off the meeting, I'd like to introduce Ryan Stevens, the department's engineering manager and champion behind the city's Cool Pavement program.
Thank you, Brandy. Good evening now, everyone. I'm Ryan Stevens, engineering manager in the Street Maintenance Division, overseeing the Cool Pavement program. Thank you for joining us today as we hear from Arizona State University about their findings on cool pavement. As you know, our city is no stranger to extreme heat, and we are continually exploring innovative ways to make our urban environment more livable and sustainable. Though we are here this evening to learn more about cool pavement, I wanted to take a brief moment to highlight what other initiatives the city is undertaking to mitigate and respond to urban heat. One program is the Cool Corridors program, also administered by the Street Transportation Department. This program aims to create shaded, cooler pathways in high traffic areas, connecting key parts of the city while providing pedestrians with relief from intense heat. Since its inception, over 3,300 trees have been planted in the right-of-way to restore trees that have been lost over time and create a more comfortable walking experience. Looking ahead, the Shade Phoenix plan is another exciting development that will expand on these efforts. The upcoming plan will focus on significantly increasing tree canopy coverage and building shade structures throughout the city to further address heat and promote public health. The $50 million investment over 5 years is a strong signal that we recognize the importance of shade, and that plan will be going to the City Council in mid-November. Since shade cannot be placed everywhere, an additional tool in our toolbox is our Cool Pavement program, which we'll be talking about tonight. Launched in 2020, Cool Pavement is designed to combat urban heat island effect by applying a reflective coating to streets, reducing surface temperatures by as much as 10 to 12 degrees Fahrenheit. Since the start of the pilot program, 107 miles of cool pavement have been applied in 27 locations throughout the city. An additional 8 miles are projected to be completed before the end of paving season this year. Before we finally begin the presentation, I want to thank ASU for their partnership in this study and recognize some of the additional ASU team members who are here tonight, Dr. Medell, Dr. Kalush, and you'll be hearing from Dr. Vanos and Jose Medina. With that, I'm happy to introduce Dr. Jennifer Vanos, the co-principal investigator for the study, who will present the research results. Please welcome Dr. Vanos.
All right. I don't want to hit any chords here. Thanks for having us. I want to thank the City of Phoenix, thank all of you for being here, for sticking it out through this time, and also highlight that the PI of this project is Dr. Arnie Medal. She's on leave right now, but is here with us tonight and might stay to answer some questions later too. We had a very large team on this project of researchers, of students across disciplines and departments, and we had really fabulous City of Phoenix liaisons as well as volunteers. So I want to acknowledge that before I get going. This is for phase 2 of our project. Phase 1 was in 2020 in the summer. Phase 2 is in 2022. So have to kind of go through just the what is reflective or cool pavement to begin with. And a lot of you know it's this range of technologies that exist largely for reducing heat on, below, above pavement. The albedo-based products reflect more solar radiation, as is shown in the image to the right. And it's often lighter in color, such as a light gray or other colors. We know it's very beneficial in reducing surface temperatures throughout the day and even into the night. And it does have a lot of potential benefits for pavement preservation, which is part of this study. So with phase 2, our bigger goal was to build upon a lot of our phase 1 pilot study and performing some repeated measures, as well as doing a new test of this Phoenix gray that GuardTop created, or Cool Seal 2.0, in response to some of the phase 1 results. So we repeated some of our temperature measurements, looked more at the material performance and durability, did some new product comparisons, and then also added some components of health and energy. We can't cover everything in this presentation, so we encourage you to check out the report and executive summary. But the way we've outlined this is going through our outdoor neighborhood field measurements, the outdoor test bed that was created, and then an indoor laboratory testing section that Jose Medina will largely present. So we'll start with our outdoor study. We looked at a residential site that's kind of northwest Phoenix area in Maryville. And as you can see here, about half of that neighborhood was covered with, coated with the Cool Seal, and then half was the traditional asphalt. And it's very tough to find areas in a city that are homogeneous. I'm gonna blame lack of sleep on that one. And we were looking for areas not close to agricultural fields, not close to excessive irrigation, not close to golf courses, not close to potentially industrial activities. This was the one we found that was being sealed. And it was a great one to use, we think. So the first, we're gonna go methods, results throughout our different tests. So with the mean radiant temperature and surface temperatures, the coating was applied start of June, and then we, within the next week, started doing measurements to start to look at these differences. We use, our main tool is the MARDI card, or mean radiant temperature. Mean radiant temperature is just thinking about what is the total radiant heat load on your body by summing up and weighting all of the different factors from the environment that influence your radiative heat gain. So from top to bottom, sides, back to front, and taking into account solar and long wave radiation. So with the mean radiant temperature cart, we're able to measure that in multiple different locations throughout the neighborhood, and then compare it to a stationary spot over in our control site in the asphalt part of the neighborhood. We do this 4 times a day to get pre-sunrise, high sun, hottest temperature of the day in the afternoon, and then post-sunset. And these are very similar, or if not the same, measurements or methods we used for the phase 1 pilot study. So very similar results for surface temperature. We saw reductions throughout the day, especially at noon and afternoon, of up to 12 degree Fahrenheit temperature reductions of the surface temperature. That's touching the surface. Your dogs are happy about that one. Very similar to phase 1 results. Mean radiant temperature, also really similar to phase 1 results. Higher mean radiant temperature in the mid-afternoon, negligible difference in the morning and evening. This also confirms phase 1 results, and I'll get more into it later, how this is important to acknowledge. It's not, we did middle of the road measurements on the sidewalk. It's no different for people walking on the sidewalk. So this will have important implications when we talk about where should this go and what should we pair it with in terms of other heat mitigation technologies. With the air temperature gradient, we wanted to use some novel methods to really get at, to try and see what was going on at different heights above the surface. So we did 0.5 meter, 1 meter, 1.5, and 2 meters on this mobile cart, and then also in a stationary setting. So with the mobile ones, we did 6 transects on September 6th. It reached 110 degrees Fahrenheit that day, so it was a good day to do these measurements. And our student, Zach Van Tol, he rode a bike with this contraption on it through these areas of the neighborhood, comparing it to also a stationary site. But we were able to just compare what are the temperatures in the cool sealed neighborhood versus part of the neighborhood and over the asphalt part of the neighborhood with this. And then we also did the stationary data collection where we put these sensors, same heights, in the cool seal part and the asphalt part. So with the results, we overall see a minor but beneficial decrease in air temperature at all of those heights, about 0.13 degrees Fahrenheit on average. And it was the highest after sunset, about 0.6 degrees Fahrenheit, which is similar to the results we found in 2020. If we look at the stationary results, we saw about 0.9 degrees Fahrenheit cooler in the cool sealed neighborhood across all heights. And then we also have to recognize that at certain times of the day, we did see this flip that we're looking into, but it might have something to do with the fact that the cool seal part was very smooth and the asphalt part, traditional asphalt, was more of a chip, so it was rougher, and so we think that resulted in it transferring heat to the environment a bit quicker after sunset, so in this area here. It's an interesting result nonetheless. This is a question we get asked about a lot. Is it higher UV radiation over the surface? So in 2022, we decided to test that. I have these UV index and UVB sensors, and on average, the cool seal percent reflectivity from the surface was lower than asphalt and concrete, just by taking the incoming and outgoing and dividing it. And that's a very promising result, so that we're able to say, no, it's not going to increase your risk of burning your skin, largely because the way the cool seal product works is it has titanium dioxide in it that absorbs those UV radiation rays instead of reflects them like some surfaces do. So that's great. And then we did do a test of afternoon heat stress, just because of that higher radiant load on a person if they're standing in the middle of the road. And we created this little infographic for the report to be able to say, here's what's happening in terms of how the radiation for the different wavelengths is being partitioned on the surface. And so with that higher shortwave radiation over the surface, and thus the higher mean radiant temperature in the middle of the day, we did some heat stress measurements to see a slightly but insignificant heat load, higher heat load on a person if they're walking in the middle of the street. There's no difference in the morning, evening, or if you're walking on the sidewalk. And then with the outdoor test bed, it was really great that the Union Hills Service Center facility in North Phoenix allowed us to apply 3 coatings, and you can see them here. We're just going to call them Cool Pavement A and Cool Pavement B for today and in the report. And then we compared that to a control of traditional asphalt. And we did MARTI measurements every 30 minutes on September 17th, where we put the MARTI cart just every 30 minutes moved throughout to get these mean radiant temperature measurements, also did surface temperature, and then we also have these reflectivity measurements that shows you the difference in reflection of the 3 surfaces we tested at the test bed. So with mean radiant temperature, very similar results again, and the negligible difference after sunset, but when we compare the 2 different types of cool pavements with this, there's no significant difference there. And then I'm going to pass it over to Jose now.
Hi, good evening again. I'm Jose Medina. So the next phase, I'm a material scientist or researcher, so we wanted to find out more about the material itself. Like, is it going to help not just mitigate urban heat island, but can it extend the service life of the pavement itself? So for that, in this test bed section, we installed different temperature sensors. One of them about a 1/4 inch from the top, and the other one about 3 inches. And we measure the different, we monitor this almost for a year to compare the difference in temperature. What I want you to see from this plot, these are the average maximum temperatures from the top. And you see a decrease when we compare it to the control. If we zoom into this image, these are the average difference between the 2 products, product A and product B, compared to the conventional black seal that we use. For product A, early in the summer, the difference was up to almost 10 degrees. But then it reduced in the winter to 4. The other one, the other product remained constant pretty much all the time. Just to get a visual assessment of the condition, the picture on the left, it's the brand new pavement. The picture on the right, you see a little bit more of wear during the wheel path of the, and it's good to mention that this facility, a lot of heavy traffic, a lot of dump trucks, garbage truck, so it has a lot of heavy traffic every day. And one of the things that we observe is, especially at the curbs, where most of the, the turning of the vehicles, that's where we observe more of the wear. Now, the other aspect that we wanted to evaluate is in the laboratory experiments. So the City of Phoenix uses in their mixes RAP, recycled asphalt millings. But we wanted to investigate, and the city was interested in investigating what could be the effect of these millings in the future when we are introducing these coatings into new pavements. How is that going to affect the performance? For that, we did some performance tests in the lab. And we compared it to a conventional RAP mix with another RAP mix that included these other products. I don't expect you to understand this graph, but the bottom line that I want to see, but I think that we can figure it out, is all these curves overlap each other, meaning that there is no difference. So in the future, if we want to apply this coating, mill the asphalt, and use those millings as a wrap for new mixes, it will not have any problems in terms of the stiffness of the material. The next test that we did is a typical tension test. We fabricate cylinders, we crush them. The students love this, they get to break something. And again, the tensile strength, as shown in the graph, has no significant difference between all of them. So again, we will not have any concern about that. And then the other test that we perform, it's called the Hamburg wheel. Basically, we place the samples and we have a wheel going back and forth 20,000 times. And usually we have as a threshold line a half an inch. So all of the products that we tested, they were way below the threshold line that we use as a specification or as a measure. So again, going back to the 3 tests that we did, there is no concern about using these materials in the future for RAD mixes. Now the other experiment, and we are developing this area in pavements is kind of new because we don't know how long is it going to improve the performance, the durability. There is no standard right now that measures the wearability of this product. So right now we are trying to investigate how can we do it. So we have a student working on this, trying different methods. We have a mixer. We condition the sample under water. We kind of torture the material because we want it to fail. And let me show you a quick video of what the test looks like. It's an 8-second video. So we condition the sample with heat and everything, and then we place it on the mixer with this brush spinning for 1 hour spinning. The way that we analyze this information, it's we take pictures before we run the test, and we do an image analysis. Like you see the picture on the left, on the top, and then the bottom, that's our initial condition. And then after we wear the sample, we analyze basically the black stuff, the black areas in the white and black pictures, and compare the before and after. That's, again, these methods are in the exploratory mode. We still need to refine them. But basically, what we have from the lab samples, usually product A were more than product B. This can be different curing times, the way of application. The other feature that we see in the right, it's it's our field cores. So the field cores for all of the sample, we see minimal wear. And it can be due to the different texture, the application. When we core this sample, it was already in the field like 2-3 months or maybe a longer time, so it got more time to cure, to bond. But these are the questions that we need to start asking and see how can we evaluate this type of coating for future application. And now, we also did, thermal properties of the materials itself. Again, I don't expect you to go over these numbers, but the outcome of this, the thermal conductivity and the specific heat capacity is for control. The black coat is going to conduct and store more heat. The product A, what it means is that going to allow less heat. It will not allow too much heat to penetrate to the pavement structure, and that will make having a lower surface temperature. And the product B will dissipate heat faster than the other one. The other test that we did is expansion and contraction of the sample, and this is just a measure to see how sensitive these materials are to temperature changes. So basically, of course, the black coating, the conventional coating, is more susceptible to temperature changes. It will expand and contract more than the other one. So I'm going to hand it back to Jenny.
Thanks, Jose. Yeah, and I'll wrap it up with two more slides, and then we'll be all done. So, in takeaways, what does all this mean? I want to highlight first the innovation here, and that Phoenix is a city leader in cool pavement implementation, testing, and really driving industry innovation. There's no way to know how this works in the real world unless you test it in the real world, and it takes a city with some guts to do that, and I think that Phoenix has done it, and especially in one of the hottest cities in the world. In terms of the surface and subsurface temperature and the product lifespan, we do see these consistent large reductions with surface and subsurface temperatures, which is important, and we hope that it means that it will increase the lifespan of this material, largely connected to decreased thermal strain that Jose was talking about. That means there could be potential economic and environmental benefits. We need more years to be able to see that come back, and I'm sure the city is really interested in seeing what happens there, but we do see promising results in that area. Air temperature, we do know they're small but beneficial. Surface temperature reductions at certain times of the day. And then the mean radiant temperature, there's a concession or trade-off there, and that means there's important implications for the siting of where you put cool pavement. It has similar results to concrete, and then that also highlights the importance of putting it in places where sidewalks exist for walking, and also pairing it nicely with other heat mitigation strategies like Ryan was mentioning at the start of the presentation. Decreased UV radiation compared to both traditional asphalt and concrete. And then we see some negative aspects of wearing on the street, but no difference between the products. So with future work and recommendations, with respect to surface reflectivity, in 2020 we were doing some nice measurements with a spectrometer to see what could be the changes over time, especially the declines across the neighborhoods in terms of how reflective it was, because it needs to be reflective to maintain the performance. And we are trying to continue to do those measurements and look at other products there as well. But we think that's a really important component of the long-term assessment of these products. And then especially working more on the durability and life cycle cost analysis that Jose mentioned there, really understanding what the potential return on investment is there long-term, and then continued assessment for the impact for wrap mixes connected to the aging and behavior.
The library will be closing in 15 minutes. Computers will turn off in 10 minutes. Please begin your final printing at this time. If you need assistance, please see a staff member. Su atención, por favor.
Oh no.
La biblioteca se cerrará en 15 minutos. Las computadoras se apagarán en 10 minutos. Comience su impresión final
Okay, final point here, but it's an important one. The placement considerations for maximum performance and minimizing trade-offs. So obviously the geography and climate matters. The city of Phoenix in a place, in a desert, which has hot temperatures and clear skies predominantly, is a good place to use a product like this. However, it does depend on where you put it. You don't want to be putting it in a place where there's lots of shade already, because then the sunlight can't interact with the surface. So we want to use these wide residential streets like it's being used on, that also contain sidewalks, and then on large parking lots that lack shade. We want to avoid high-rise downtown areas so that we get that interaction of sunlight with the street. And then we want to pair with those complementary heat mitigation strategies, and then avoid areas that have high midday traffic, like playgrounds, like plazas, like courtyards, and parks. And we think that's a really important point, and know that the city of Phoenix has definitely heeded that recommendation, so we're thankful for that. With that, we are happy to take questions. I think Jose can come up here, Ari's still here, Camille's here, and here are our emails if we can't get to all your questions, but thank you.
Thank you, Dr. Vanos, for the presentation, and Jose. We will take Q&A from the audience if there is any, but I did want to also put that all the information about our studies, I presume the recording of tonight's event will be on our Cool Pavement webpage, which is Phoenix.gov/streets/coolpavement. And any of you who are listening at home and have questions or want to get in touch with the team, you can email us. That's pavement@phoenix.gov, and that's also on the website. So thank you again for all of you who are here and all of you who are hopefully with us virtually. We will take any questions from the floor, and then we will move to the back of the room and take questions from our media partners.